Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, ma'am.
Good evening, ma'am.
Okay, cameras on, please. Thank you. Good evening. All right. So we started with exponents. We finished 12 subdivisions of question number 1 in the last class. Let's continue. Yeah, so this is the second question, children. And this kind of looks like of 8th standard. So I think I'll just give you some time to try this. Try this one, children. Write down the question. Okay, and before that, have you all completed? Because last class we all took screenshots of the answers, right?
Yes, ma'am.
Yes, yeah. One by one, tell me how you finished writing out all of those in your classwork.
Finished one.
Finished, ma'am.
Finished.
Finished,
Finished, ma'am.
No, I can't make out. Okay, Krishmika Shri, finished?
Yes, ma'am.
Madhumita?
Ma'am, I'll complete it by today, ma'am.
Okay, no, that don't forget. Netra?
Yes, ma'am. Completed.
Ryan?
Yes, ma'am. Completed.
Okay, Prajakth?
Completed, ma'am.
Very good. Raja?
No, ma'am, I completed by today.
Please complete.
Yes.
And yeah, you told me that you were out of station. Right. Okay. You're now in Trichy?
Yes, ma'am.
Okay, good. Sanjay and Sindhu?
Completed, ma'am.
Very good. And Krishmi also, I think you wouldn't have had time to complete, right? Krishmi, can you hear me? Shri Krishmi? Shri Krishmi, can you hear me? I can't hear you. Okay, please complete. If you have not completed, please complete. Oh, done now. Very good, very good. Okay, thumbs up. Very good. Okay. All right. Fine, children. Yes. Recall from 8th standard. Find the value of x.
Ma'am, I found the answer.
Okay. Let's wait for the others. Okay, Madhumita, what's the value of x?
Ma'am, I got 4.
4. Okay.
I got the same answer.
You two got the same answer, 4. All right. So 7 by 9, the whole power 8 into 7 by 9, the whole power 4. is equal to 7 by 9, the whole power 3x. So bases are same. Bases are same. So we need to add the powers. So 7 by 9, the whole power 8 plus 4 is equal to 7 by 9, the whole power 3x. So we have 7 by 9 to the power 12 is equal to 7 by 9 to the power 3x. So on both the sides, the bases are same. So we equate the powers. 3x is equal to 12. X is equal to 12 by 3. X is equal to 4. So some of you might not understand this one. I'll tell you. Write down the answer in your notebook. I'll tell you. Please write the answer. I'll tell you how this happens. All right. So now we need to understand how to write the equivalent of an exponential expression. So see here. Now supposing I have 2 by 3, the whole power 5. Now remember these two lines. Now an exponential form has two aspects. An exponential form has two aspects. One is the base. One is the base. Okay. And the other is the power. The other is the power, or the power is also called the index. The power is also called the index. It's also called the exponent. It's also called the exponent. Now here in this one, 2 by 3, the whole power 5. 2 by 3 is called the base. 2 by 3 is called the base and 5 is the power. Now what are we going to understand? We're going to understand how to write the equivalent of 2 by 3, the whole power 5. Now remember these two lines. Reciprocal of the base, negative of the power. Write down somewhere in your book. Reciprocal of the base. Reciprocal of the base. Negative of the power. Negative of the power. These two lines you need to remember in order to write the equivalent of an exponential expression. See, base and power are the two aspects, are the two parts of an exponential expression. Base and power. What should you do with the base? Reciprocal of the base. What should you do with the power? Negative of the power. Negative of the power. So the equivalent of 2 by 3 to the power 5 is equal to, take the reciprocal of the base, 3 by 2. Write the negative of the power. 5 means minus 5. Now these two are equal. These two values are equal. You can write 2 by 3, the whole power 5, as 3 by 2, the whole power minus 5. Both are the same. Both are the same. Let's take another example. Now supposing we have 10 by 7, the whole power minus 3. Okay, so its equivalent is take the reciprocal of the base. Take the reciprocal of the base. What is the reciprocal of the base? 7 by 10. Negative of the power, minus 3 will become plus 3. So 10 by 7, the whole power minus 3 can also be written as 7 by 10, the whole power 3. Reciprocal of the base. 10 by 7 is the base, so 7 by 10, reciprocal. Negative of the power, minus 3 becomes plus 3. Now, supposing this was minus 10 by 7, it will come as minus 7 by 10. Don't change the sign here. Reciprocal of the base. Just invert the base. So if it was minus 10 by 7 here, it will be minus 7 by 10 here. If it was minus 10 by 7 here, reciprocal is minus 7 by 10. Reciprocal of the base, negative of the power, minus 3 becomes plus 3. The negative of 3 is minus 3. The negative of minus 3 is plus 3. The negative of 5 by 7 is minus 5 by 7. The negative of minus 5 by 7 is 5 by 7. Just change the sign. Just write the opposite sign. So here, what will be the equivalent of 9 by 7 to the power minus 4? Reciprocal of the base. 9 by 7 becomes 7 by 9. Negative of the power, minus 4 becomes plus 4. Why are we doing it? So that the bases are same now. 7 by 9, 7 by 9. Bases are same. So you can use the law of exponents. Bases are same and it's multiplication. So you can add the powers. Now in the question, the bases are different. In the question, the bases are different. 7 by 9, 9 by 7. They are different. So you want to make this 9 by 7, 7 by 9. You can make it 7 by 9. Take the reciprocal of the base and write the negative of the power. Minus 4 becomes plus 4. So now what happens? The bases are same. 7 by 9, 7 by 9. And it's multiplication. So we add the powers. So next step you can see. 7 by 9 is the base. We add the powers. 8 plus 4 is equal to the RHS as it is. 7 by 9 to the power 3x. Now again we have another rule. Okay, so now this 8 plus 4 becomes 12. So at this stage we have a rule again. Now you can see this equal to sign, and there is only one expression in the LHS and one expression in the RHS. See, there's only one expression in the LHS. 7 by 9 the whole power 12. In the RHS, 7 by 9 the whole power 3x. At this stage, when you come across something like this, look at the bases. 7 by 9, 7 by 9. Bases are same. So you can ignore the bases. Don't cancel them. They don't get cancelled. I'm just cancelling it so that you understand. So like 7 by 9 and 7 by 9 gets cancelled on both the sides. You should not cancel, children. So like that. So equate the powers. 3x is equal to 12. So we say bases are same on both the sides. Equating the powers, we get 3x is equal to 12. X is equal to 12 by 3. X is equal to 4. Now you need to know one more thing. How to write the reciprocal of an exponential expression. We need to also understand how to write the reciprocal of an exponential expression. All right, we'll see that now. Now, supposing we have, we'll take the same thing. So 9 by, sorry. Yeah, supposing we have 9 by 7, the whole power minus 4. Now, what are the two lines we have to remember? Reciprocal of the base. Reciprocal of the base. This is one thing. Reciprocal of the base. See, base and power are the two things. What do you do with the base? Reciprocal of the base. What do you do with the power? Negative of the power. Negative of the power. Negative of the power. Now, when you apply both to the expression, to the exponential expression, you are writing the equivalent. When you apply only one of these two, any one of these two, you are writing its reciprocal. Now I'm going to apply only one of the, see, I'm not applying both. If I apply both, see now if I apply both, meaning reciprocal of the base 7 by 9, negative of the power 4. That means these two are equal. I'm writing the equivalent. Now I want to write the reciprocal of, what is the reciprocal of 5? 1 by 5. Are they equal? 5 and 1 by 5? No. The reciprocal of 5 is 1 by 5. 5 and 1 by 5 are not equal. The reciprocal of 5 is 1 by 5. Am I clear, children? Am I audible and clear?
Yes, ma'am.
All of you?
Yes, ma'am.
Very good, very good. All right. So see, 5 is not equal to 1 by 5. We say the reciprocal of 5. You should write that the reciprocal of 5 is 1 by 5. You cannot write 5 is equal to 1 by 5. Similarly, the reciprocal of 9 by 7, the whole power minus 4 is. What is the reciprocal? You can write the reciprocal in two ways. Okay, so apply any one rule. Now, supposing you take the reciprocal of the base, 7 by 9. Write the power as it is. Write the power as it is. So the reciprocal of 9 by 7, the whole power minus 4 is 7 by 9, whole power minus 4. Why is it the reciprocal? Because I have not applied both. I've applied only one of the two. What did I do? I've taken the reciprocal of the base. 9 by 7, I've written as 7 by 9. But that minus 4, I wrote as it is. That means I've written the reciprocal. The reciprocal of 9 by 7, the whole power minus 4 is 7 by 9, the whole power minus 4. Or the reciprocal is also, if you write the base as it is, 9 by 7 as it is, write the negative of the power, 4. You're making only one change. You're writing 9 by 7 as it is. See here, you wrote the reciprocal of the base and you wrote the power as it is. Here, you're writing the base as it is and you're writing the negative of the power. Let me clear the slide and write it again for you. 9 by 7, the whole power minus 4. The reciprocal I'm writing, the reciprocal of 9 by 7, the whole power minus 4 is, I'm taking the reciprocal of the base. I'm writing the power as it is. Or the reciprocal of 9 by 7 to the power minus 4 is, I'm not taking the reciprocal of the base. I'm writing 9 by 7 as it is. So then make minus 4 plus 4. So if you apply one of these two rules, you are writing the reciprocal of the given exponential expression. If you apply both the rules at the same time, you are writing the equivalent of the given exponential expression. Am I clear, children?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. Now, while solving reciprocal, when should you write the reciprocal? Only when they ask you to write, you should write the reciprocal. Otherwise, you will be writing only the equivalent. Children, you can make a note of this if you want. I'll just give you some time. This of 8th standard. This is recall from 8th standard, children. You can just give an example. You can just say example and make a note somewhere. You can write the reciprocal in two different ways. All right, children, let's go to the next one. So this is again very simple. So see here. So we are given that 5 to the power 3x is equal to 125. 125 can be written as 5 to the power 3. 125 can be written as 5 to the power 3. 125 is equal to 5 to the power 3. So 5 to the power 3x is equal to 5 to the power 3. Again, base are same on both the sides. So equating the powers, 3x is equal to 3. X is equal to 3 by 3, which is 1. So find the value of x. X is equal to 1. Now let's find the value of y. Now 10 to the power y is equal to 0.001, which can be written as 1 by 1000. 0.001 is equal to 1 by 1000. 0.001 is equal to 1 by 1000. Because see here, 1, 2, 3 places we'll have to shift. The decimal we'll have to shift by 3 places. 1, 2, 3 places. So 1 by 1000, 3 zeros. 3 zeros. So 10 to the power y, 10 to the power y is equal to 0.001. 10 to the power y is equal to 1 by 1000. 10 to the power y is equal to 1 by 10 cubed. You understand? 1000 is 10 cubed. 1000 is 10 cubed. Now this is nothing but 1 by 10. 10 cubed is also 1 by 10 the whole power 3. Because 1 cubed is 1, 10 cubed. 1 by 10 the whole 1 by 10 to the power 3 is also 1 by 10 the whole power 3. So now how do you write the equivalent? Reciprocal of the base, negative of the power. That's how you get 10 to the power minus 3. You should write the equivalent in the next step. Let me write it here for you, children. Let me write it here for you. See here, 10 to the, please watch again. 10 to the power y is equal to 0.001. That's the first step. 10 to the power y is equal to 1 divided by 1 followed by 3 zeros. Next step, 10 to the power y is equal to 1 by 10 cubed. Now this is nothing but 1 by 10 the whole power 3. 1 by 10 the whole power 3. Both are the same because 1 cubed, see here 1 cubed is 1 and 10 cubed is 10 cubed here. Now 10 to the power y is equal to, now how do you write the equivalent of this one? Reciprocal of the base 1 by 10 is 10, negative of the power minus 3. Now the bases are same on both the sides, 10, 10. Equating the powers, we get y is equal to minus 3. Maybe here 2 steps are not there. This is correct. I'm not saying it's wrong. 2 steps are not there. You can take down this one. Write down fast. Quickly write down, children. Done, children?
Yes, ma'am. 1 minute, ma'am.
Yes,
Okay,
ma'am.
okay. Yeah.
Ma'am.
Completed, ma'am.
Yeah, children. Yeah. So what is yeah. What is 1 cubed?
1, ma'am.
1. 2 cubed?
8, ma'am.
8. 3 cubed?
27.
26. The whole power minus 3 by 2. What is the sum? What is 1 plus 8? 9. 9 plus 7?
36, ma'am. 36, ma'am.
36 to the power minus 3 by 2. And how do you write 36 in the exponential form?
4 to the power 3.
36 in the exponential form, children.
6 to the power 2, ma'am.
6 to the power 2. See? Just a second, children. Sorry. Yeah, sorry, children. Yeah. So what is 36? 6 to the power 2. 6 to the power 2. The whole power minus 3 by 2, correct?
Yes, ma'am.
So what do you do when you have multiple powers?
Add power 2 into minus 3 by 2.
2 into minus 3 by 2.
By 2.
The powers. Multiply the powers. When you have many powers, the base is 6. It's raised to the power 2, whole power minus 3 by 2. Multiply the powers. So 6 to the power minus 3. How do you write the, now 6 to the power minus 3 cannot be calculated because now what do you mean by 6 to the power? What do you mean by 6 to the power 3? 6 has to be multiplied with itself 3 times. What does the power say? 8th standard. What does the power say? The power says how many times the base has to be multiplied with itself. What does the power say? What does the power indicate? The power says how many times the base has to be multiplied with itself. So 6 to the power. So I can tell you, you go around the field once, go around the field 2 times, go around the field 3 times, 4 times, 5 times. If I say minus 3 times, you laugh at me. So number of times cannot be negative. Number of times cannot be negative. But we have a value 6 to the power minus 3. You have to calculate its value. So you have to make the power positive because the power says how many times the base has to be multiplied with itself. So now, so if it was 6 to the power 3, if it was 6 to the power 3, it's easy. The base 6 has to be multiplied with itself 3 times. So 6 into 6 into 6. Why 6 into 6 into 6? Because 3 times. This one says number of times. Number of times. So 6 into 6 into 6, which is 216. Here I have 6 to the power minus 3. Minus 3 times, no. But you have to calculate the value. So you should write the equivalent of 6 to the power minus 3. You will have to write the equivalent of 6 to the power, 1 second children. You need to write the equivalent of 6 to the power minus 3. How do you write the equivalent? Reciprocal of the base, negative of the power. Reciprocal of the base, negative of the power. What is 6? 6 means 6 by 1. Let's finish this, children. Let's finish this. So 6 means 6 by 1, correct? Reciprocal of 6 by 1 is 1 by 6. Reciprocal of the base, negative of the power. Negative of the power. So 3. Now the power is positive. So now what does it mean? Multiply the base 1 by 6 with itself 3 times. Multiply the base 1 by 6 with itself 3 times. 1 by 6 into 1 by 6 into 1 by 6, which is 1 by 216. Yes, somebody wanted to ask something. Oh, okay. I thought somebody wanted to ask. Okay, 1 second. All right, children. So you can see the answer slide here. Please write down. So for students who want it more clearly, you can just do it like this. After the step, these steps are correct, children. I'm just including more steps for clarity. So after this step, after this, you can write, this is nothing but 6/1, the whole power minus 3. After this step, you can continue like this. This is nothing but 6. This 6 means 6/1. 6/1, the whole power minus 3. So reciprocal of the base, 1/6. Negative of the power, 3. So this is nothing but 1/6 into 1/6 into 1/6, which is equal to 1/216. You can write down like this. After this step, you can continue like this. After 6 to the power minus 3, this means 6/1. 6 means 6/1 to the power minus 3. Reciprocal of 6/1 is 1/6. Minus 3 becomes plus 3. So you have written the equivalent. You have written the equivalent. Done, children?
Yes, ma'am.
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am.
Just a minute.
Okay. So what is the reciprocal of minus 3/7, the whole power minus 5? What is the reciprocal of this? Let me ask somebody. Is Raja there? Yes, Raja. What is the reciprocal of minus 3/7, the whole power minus 5?
Ma'am,
Ma'am.
minus 3/7
Any one way. Minus 3/7
to the power 5.
to the power 5. Okay. Krishmika Shri, what is the other way of writing the reciprocal?
Minus 7/3 to the power minus 5.
Very good, very good. So when you apply only one of the two rules, you're writing the reciprocal. Now, they're not equal. The reciprocal of this one is this. The reciprocal of this one is this. You can write it in two different ways. Very good. Okay. Yeah, this is the next question. Write on the question. I'll just get back, children. Write on the question. Yes, children. So we must start simplifying from the innermost bracket. Okay. We should start simplifying from the innermost bracket. So see here, I'm writing the square bracket. I'm writing the square bracket as it is. I'm writing the square bracket as it is. I'm writing that 5 as it is. Here, I'm writing 8 as 2 cubed because you all know that 8 is 2 cubed. And there's already a power 1 by 3. So it will be into 1 by 3. Now you should understand this. 8 is 2 cubed. 8 means 2 cubed. 2 into 2 into 2 is 8. To 8 is 2 cubed, but 8 is already raised to the power 1 by 3. So into multiply the powers. When there are many powers, multiply the powers. Plus 27 is 3 cubed. 3 cubed because 27 is 3 cubed. Why? 3 into 3 into 3 is 27. 3 cubed. But there's this 1 by 3 there. There is this 1 by 3 there. Correct? This 1 by 3. This 27 is 3 cubed, but there's this 1 by 3 there. So multiply into 1 by 3. Into 1 by 3. Now can you see the bracket is closed? Close the bracket. Then can you see this 3? Can you see the 3 here? See this 3 here? So write the 3. Write the 3. Then close the square bracket. And raise it to the power 1 by 4. So what we've done here is we've written 8 as 2 cubed and 27 as 3 cubed. And there was already the power 1 by 3 for both. We multiplied that power. Now 3 and 3 gets cancelled. 3 and 3 gets cancelled. Because 3 into 1 by 3, no, 3 into 1 by 3. What will happen? You will cancel this 3 and 3. Okay, so next step. Next step, write the 5 as it is. Open the simple bracket. 2 power 1, so it is only 2. 2 power 1, it's only 2. Plus 3 power 1, it's 3. Close the simple bracket. What is there? 3. Write the 3. Then the square bracket. And then that power 1 by 4. Next step. 2 plus 3, 5. So is equal to, see, start the simple, start the square bracket. Write that 5. Open the simple bracket. 2 plus 3 is 5. See here, 2 plus 3 is 5. Close the simple bracket. Power 3. After the power 3, there's a square bracket. Then there's this 1 by 4. Now this is nothing but open the square bracket. 5. 5 cube. No, so it's like 5 into 5 cube. It's like 5. It's multiplication. There's no sign. It's multiplication. 5 into 5 cubed. See here, 5 into 5 cubed. Close the square bracket. 1 by 4. How do you handle this? Bases are same and it's multiplication. So we add the powers. Here the power is 1. No power means 1. So it will be 5 to the power 1 plus 3. 5 to the power 1 plus 3. Add the powers. Bases are same and it's multiplication. Add the powers. 8th standard. And then now you can change the square bracket to simple bracket. But if you're like very particular, you can use the square bracket itself to the power 1 by 4. You can change it to a simple bracket. Next step. Next step.
5 power 4 into 1 by 4.
Yeah, 5 to the power 4 into 1 by 4. 4 and 4 gets cancelled. So the answer is 5. All right.
Yes, ma'am.
Same thing. Right? Write down. Carefully write down. Done, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right.
Ma'am,
So
no.
same one.
Excuse me, ma'am.
Tell me.
I have not completed it, ma'am. Just a minute.
Yeah, sure. Sorry.
Completed, ma'am.
Very good. Right, children. This is a similar one. This is a similar one. So see here, open the square bracket. Please listen to me, children. Don't try to do it on your own. So open the square bracket. 9. 64 is what, children? 64 can be written as 4 to the power 3. Then into 1 by 3. Correct?
Yes, ma'am.
Plus, what is 125?
5 to
5 power 3.
5 power 3. See, children, 64 is 4 into 4 into 4. So 4 cubed. And 125 is 5 into 5 into 5. So 5 cubed. 5 cubed. So 5 cubed. Into, there's already the power 1 by 3. So into 1 by 3. Close a simple bracket, raise it to the power 3. You can see the power 3 there. Close a square bracket, raise it to the power 1 by 4. Now what happens? 3 and 3 cancels. 3 and 3 cancels. So here inside we have 4 plus 5. So open the square bracket. 9. Simple bracket. 4 plus 5 is 9. Because 4 to the power 1. 4. 5 to the power 1. 5. So 4 plus 5, 9. Close a simple bracket. You can see the power 3 here. Raise it to the power 3. Close a square bracket to the power 1 by 4. So now inside you have 9 into 9 cubed. 9 into 9 cubed. 9 to the power 1 into 9 cubed. The whole power 1 by 4. So bases are same. 9, 9. Bases are same. So add the powers. 1 by 3. The whole power 1 by 4. So it's 9 to the power 4 into 1 by 4. 4 gets cancelled. 9 is the result. Yeah, children, please write down.
yes, ma'am.
See, the brackets are used in this order. OK, the brackets are used in this order. So I don't know if you've heard of this vinculum. Vinculum is also a bracket. Vinculum, yes, we don't learn it in the CBSE syllabus. Vinculum is, again, that's the innermost bracket. Vinculum is the innermost bracket. So you wouldn't have come across that. So
Ma'am,
we
can you
see.
spell it, ma'am?
No, leave it. That's all part of 6th standard, 6th and 7th standard. Don't worry about that now.
Okay, ma'am.
Yeah. It's a part of 6th, 7th standard when we start integers. Okay, so it's okay. Vinculum is the innermost bracket. Vinculum. Okay. So then after the vinculum comes a simple bracket. Then the square bracket. And then the curly bracket or the flower bracket. This is called the simple bracket. Simple bracket. This is called the square bracket. This is called the curly or flower bracket. Curly bracket or flower bracket. So you can see I use it in that order. Simple bracket. Then if you use a simple bracket, then the square bracket. If you use a square bracket, then it's the curly bracket. So you can see this one is here. I'll explain this. See this one, you can see it here, children. See your children. See the screen. See your screen. This one is this one. Then the plus sign. This one is this one. Now, since I've used a simple bracket here, what do you see? These two are raised to the power 3, no? These two are raised to the power 3. So I have, because this is, you can again put a simple bracket. That's all. Nothing wrong. You will not lose marks for that. You will not lose marks for that. So let me tell you again. This one is this plus this one is this. And now you can see the simple bracket here raised to the power 3. I have used the square bracket. I have used the square bracket raised to the power 3. Then outside there is that 9. No, see that 9 here outside. Then there's a square bracket. This one, the whole thing is raised to the power 1 by 4. So I've used a curly bracket. Whole thing is raised to the power 1 by 4. You can start writing from inside if you want. You can start writing from inside. I don't want anyone to have a doubt that. So see here, children, 4 to the power 3 into 1 by 3 from inside plus 5 to the power 3 into 1. OK, this bracket I've used. OK, sorry. 4 to the power 1 minute. 4 to the power 3, the whole power 1 by 3 plus 5 power 3, the whole power 1 by 3. Now after this, what this one we have written. This one we have written. Now whole power 3. So I've used this one. Whole power 3. Then what? There's a 9 there. OK, there's a 9. OK, then the whole thing is raised to the power 1 by. See here, the whole thing, the entire thing is raised to the power 1 by 4. So I put a curly bracket like this and I raised it to the power 1 by 4. Please understand what you're writing.
Yes, ma'am.
All right. So the value of the given expression is 9. The value of this one is 9. What is this is equal to 9? The value of the given expression, this one is equal to 9. 1 second, children, I'll just get back. Done, children?
Yes, ma'am.
Yes, ma'am.
Ma'am, 1 minute, ma'am.
What happened? You want to check something?
Ma'am, last day. Yes, ma'am.
Okay.
Thank you.
Yeah.
Thank you, ma'am.
All right. Yeah, thank you. So this is the next one. Tell me. Yes, start. Yes, children, how do we start?
9 cube power minus 1 by 3.
Who's that 9 cube?
3 cube.
Sorry, ma'am. 3 cube.
Yeah. Okay, we'll understand what is 9 cube. What is 9 cube? 9 into 9 into 9. 9. We get confused. 9 threes are 27. No, so we feel 9 cube. Okay, so 9 cube, 9 into 9 to 9. 9 nines are 81. 81 nines are 729. You should be careful. We know it. We all know that. Yeah. Okay. So 27 is 3 cubed. 27 is equal to 3 cubed because 3 into 3 is 9 into 3 is 27. 3 threes are 9, 9 threes are 27. Okay. So 27 should be written as 3 cubed. And then this that power minus 1 by 3. So into minus 1 by 3. And there is no connector. There is no sign here. That means it's multiplication. So into 3 to the power 3. Again, the same thing. 3 to the power 3 into minus 1 by 3. Then into square bracket 3 power 3 into 1 by 3 minus 3 power 3 into 2 by 3 because the power is 2 by 3 there. I don't have to explain. I think all of you understood. So this is equal to 3 and 3 gets cancelled. 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 So now we have 3 to the power minus 1 here, children. 3 to the power minus 1. Don't forget that. 3 to the power minus 1 into 3 to the power minus 1 into, in the square bracket, what do we have? 3 to the power 1, which is 3 minus 3 to the power 2, which is 9. Now what is 3 to the power minus 1? It's not 3. It's nothing but 3 by 1, the whole power minus 1. 3 to the power minus 1 means 3 by 1. 3 means 3 by 1. 3 means 3 by 1. So it's 3 by 1 to the power minus 1. How do you write the equivalent of this?
1 by 3.
Of the base. 1 by 3.
1 by 3.
Negative of the power 1. So that's nothing but 1 by 3. That's nothing but 1 by 3 because when the power is 1, you can just ignore it. When the power is 1, you can just ignore it. So if you cannot, so next step, you should be able to write 1 by 3 straight away. If you're not able to write that in the rough work, you go in the rough column, you just write 3 to the power minus 1. This is nothing but, 3 by 1, the whole power minus 1, because 3 means 3 by 1. And reciprocal of 3 by 1 is 1 by 3. Negative of minus 1 is plus 1. So it's 1 by 3 into 1 by 3 into 3 minus 9. What is 3 minus 9?
Minus 6.
Now 3 ones are 3 twos are. So the answer is minus 2 by 3.
Yes,
The
ma'am.
answer is minus 2 by 3.
Yes.
Down. See, what you're expected to do is when I'm teaching, you're supposed to look at the screen and understand. And when I give you time, you're supposed to write down. If you're writing when I'm teaching, and if you feel you've not understood, I'm not going to repeat the explanation again because when I explain, you have to listen. You can ask doubts. But some of us start writing. When I'm explaining, you are writing. So if you don't understand, it becomes difficult. I give you time to write. Now you can write. Yes, children, please write down. Done, children?
Yes, ma'am.
Ma'am, last step, ma'am. Just
Completed, ma'am.
All right.
yes, ma'am. Completed.
Okay. This is the first one. Fine. So here, yeah, let's recall this. How do we write this in the exponential form? This is the radical form. How do you write this in the exponential form? X to the power x squared.
To the power 1 by 3, ma'am.
X squared to the power 1 by 3. So that's nothing but x to the power
2 by 3, ma'am.
2 by 3. X to the power 2 by 3. Because 2 into 1 by 3. 2 into 1 by 3, which is 2 by 3. Correct. Correct, Sindhu. What is fifth root of y? How do you write fifth root of y in the exponential form?
Y 1 by 5.
To the power 1 by 5.
Y to the power 1 by 5. All right. We've already seen this earlier. So now square root of x. Square root of x. X to the power 1 by 2. See, this is the question, children. This is the expression given. From here to here is the expression given. Okay. All right. So now you can see the square root of x. X to the power 1 by 2. Because square root of x means x to the power 1 by 2. To the power minus 2 by 3. To the power minus 2 by 3. Then there is no sign here. That means into. It's into. So that into here. Into. Y to the power 4. Y to the power 4. Then square root. So that means the whole power 1 by 2. The whole power 1 by 2. Then division. Division. And under the square root, we have xy to the power minus 1 by 2. So you can see that xy to the power minus 1 by 2. Then if you remove the square root symbol, it is the whole power 1 by 2. So we have got rid of the radical form. We've expressed in the exponential form. Is the first step understood? First step?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, now I want you to answer this. What is the value of ABC square? What's the value of ABC square? Meaning simplify it and tell me what is ABC square?
A into B into C into C, ma'am.
A into B into C into C. So that means it is ABC square only, right?
Yes, ma'am.
Yeah, correct. What is ABC the whole square?
Ma'am, that is every A into A into B into B into C into C.
Yeah, so the final answer?
A square, B square, A.
A square, B square, C square. That's a difference. So here you should watch out. This power minus 1 by 2 is only for y. It is not for x. The power minus 1 by 2 is only for y. It's not for x because it is not xy whole power minus 1 by 2. It's not like this. It is x y power minus 1 by 2. Watch that. It is x, y power minus 1 by 2. So be careful there.
Yes, ma'am.
Yeah. Okay, next step. Multiply the powers. 1 by 2 into minus 2 by 3. 4 into 1 by 2. Then divided by, see here, this power 1 by 2 is for x and y. This power 1 by 2, this bracket and whole power 1 by 2 is for x and y. So x to the power 1 by 2. Y is raised to the power minus 1 by 2 and the half. So multiply the powers. So it will be minus half into 1 by 2. So minus 1 by 4. Multiply the powers, multiply the powers. Here for x, you have only 1 by 2. For y, we have the power minus 1 by 2 and 1 by 2. So minus 1 by 2 into 1 by 2, which is minus 1 by 4. So now next step, this is a product divided by this. This product divided by this. So see here, I've written it like this. We are more comfortable using this division symbol like this. So you can see here this product, you can see it in the numerator divided by this. So you can see that here. I have nothing. I just made it like this. Next, by the law of exponents, when bases are same and its division, we subtract the powers. When bases are same and its division, we subtract the powers. Law of exponents, when bases are same and its division, we subtract the powers. X, base are same and its division, so we subtract the powers. So write the base x and subtract the powers. Minus 1 by 3, minus 1 by 2. Into, the connector is into. Again, base are same, y. It's division, so subtract the powers. So when you subtract the powers, it will be 2 minus 1 by 4. You'll have to subtract the powers. One power is 2. The other power is minus 1 by 4. You'll have to subtract the powers. So it will become 2 plus 1 by 4. That's what you see here. 2 plus 1 by 4. I'll tell you again. You'll have to subtract the powers. It will be, the power is 2 and the powers are 2 and minus 1 by 4. You need to subtract. This is one power. This is the other power. You need to subtract the powers. So it becomes 2 plus 1 by 4. Then, you'll have to take the LCM here and LCM here. I'm not explaining LCM part. So after taking LCM, you get minus 2 minus 3 by 6. Here, after taking LCM, 4 2s are 8. 8 plus 1. See, 2 plus 1 by 4. If you not take the LCM, by 1 it is. So 4 is the LCM. So 1 into 4 is 4. So into 4, 8. Plus 4 into 1. So 1. LCM. Then it becomes minus 5 by 6 and 9 by 4. So in very simple words, when the power is negative, if you want to make it positive, when the power is negative and you can leave the answer like this. That's one thing. You can leave your answer like this. But if you want to make a negative power positive, you just change the position. You can remember it easily like this. Supposing the index is, the power is negative, you want to make it positive. Change the position, that's all. That means you take right. That means you can make the negative power positive. Where is it? It's in the numerator. Write it in the denominator. It will become a positive power. Y to the power 9 by 4. See here, y to the power 9 by 4. Now this one has a negative power. You want to write it in the positive form. You want to make the power positive. Just change the position. It's in the numerator. Put it in the denominator. The power will become positive. Now, if you want to know why, what is this rule, you apply the usual rule. How do you how do you write the equivalent of this one? How do you write the equivalent of x to the power minus 5 by 6, reciprocal of the base 1 by x, negative of the power 5 by 6? So x to the power 5 by 6 comes to the denominator. Write down, children. I'll just come back in 2 minutes. Please write down. Done, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right. Now the others, you're going to take screenshots and complete it. We'll understand in the next class on Tuesday. I want you to think, take screenshots, complete them in your notebook. we'll discuss in the next class.
Yes, ma'am.
Taken, ma'am.
Oh, sorry.
Taken, ma'am. Ma'am.
Yeah.
Taken.
So you can see here in this one, the x to the power -1. I want to make the power positive. So I just change it's in the numerator, put it in the denominator. It's in the numerator. Just take it to the denominator. So it will become x to the power 1. That means x. That means x.
Taken, ma'am.
Taken, ma'am.
All of you?
Yes, ma'am.
Yes, ma'am.
Taken, ma'am.
Right.
Taken, ma'am.
Taken, ma'am. 1 second, ma'am.
Yes, ma'am.
Taken, ma'am.
Yeah, okay.
Taken, ma'am.
Taken, ma'am.
Second, ma'am.
Taken, ma'am.
All right. So please complete all this in your notebook. Try to understand as much as possible. Don't just, use the screenshot and blindly write down. As much as possible, try to understand. So when we discuss in the next class, it will be more clear.
Yes, ma'am.
That's all, ma'am.
Meaning in this heading, under question number 5, we have 6 subdivisions. That's all.
Okay, ma'am.
Yeah. One minute. You just do this and wind up the class for today. We'll work this and wind up the session for today. Write
Yes,
down
ma'am.
this. Yeah, please write down this one. All right. So it goes like this. Shall we start?
Yes.
Yes, ma'am.
Yeah.
Yes, ma'am.
Since 16 can be expressed in base 4. See, 16 can be written as 2 to the power 4. 16 can also be written as 4 squared. But there's a 4 here. Since there's a 4 here, I'm sorry, here, you can choose to write 16 as 4 square. Or you can write both in base 2. You know that 4 is 2 square. 4 is 2 square. 16 is 2 to the power 4. So that's your choice. The thing is, we are trying to have a common base. I think I'm done with 4. Okay. You can do it with 2 also. The thing is, you should have a common base. The base here is 4. Forget this one. Forget this. In the LHS, here the base is 4. Here the base is 16. We can have both. This is 4. We can bring this also to base 4. We can bring this also to base 4. We can bring this also to base 4. You can also write both in base 2. 4 as 2 squared and 16 as 2 to the power 4. Okay. Okay. So 4 to the power 2x minus 1 minus 4 squared. 4 squared. 16 is 4 squared. There's also that power x minus 1. So into x minus 1 is equal to 384. 4 to the power 2x minus 1 minus 4. 2 into x is 2x. 2 into minus 1 is minus 2 is equal to 384. Now you cannot say bases are same, and when for plus minus we don't have any law. Laws of exponents are only for multiplication and division. When bases are same and it's multiplication, we add the powers. When bases are same and it's division, we subtract the powers. When there is subtraction here, we don't have a law. So now what you have to do is to simplify this further, we need to take out something common. We need to take out something common between these two. Supposing I take out, you will understand. Now just listen to me. Suppose you take out 4 to the power of 2x minus 2 common. See, like when you have a squared and a cubed, want to take out a square common? And in the bracket, you will write 1 minus a. Similarly, between these two, I'm taking this 4 to the power of 2x minus 2 common. Then what will I get inside the bracket here? 4 to the power 4 to the power 2x minus 2. Now I should get 4 to the power 2x minus 1. Minus 1 I must get. I must get minus 1 as the answer. Minus 1. This minus 2 should become minus 1. How will minus 2 become minus 1? If you add 1 to it. If you add 1 to it. See here. Sorry. First time when you listen, no, it might sound very difficult, but when you revise, it will become easy. We have 4x minus 2, sorry, 4 to the power 2x minus 2 common. Now you want that minus 2 to become minus 1. See here, minus 1 it is. This into what will give you 4 to the power 2x minus 1. So how will minus 2 become minus 1? Minus 2 should become minus 1. That means you should add 1. Minus 2 plus 1 is minus 1. So what you should do is, by the law of exponents, this is a very important question. 4 to the power 2x minus 2 into 4 to the power 1. Multiplied by 4 to the power 1. What will you get? 4 to the power 2x minus 2 plus 1. So it will be 4 to the power 2x minus 1.
Yes, ma'am.
We'll do it again in the next class, so it will become easy. 4 to the power 2x minus 2 is outside common. It should be multiplied by 4 to the power 1 to get 4 to the power of 2x minus 1. Because bases are same and it's multiplication, so we add the powers and you'll get 2x minus 1. Minus 2 plus 1 is minus 1. So here I must write 4 to the power 1. 4 to the power 1 I must write. Because when you multiply these two, 4 to the power of 2x minus 2 into 4 to the power 1. Add the powers and you will get 4 to the power 2x minus 1. Minus minus this into what will give you this. The same thing is outside common, so I should write 1 here. So let me write that clearly. I'm taking 4 to the power 2x minus 2 common. Now this into what will give me 4 to the power 2x minus 1. So 4 to the power 1 minus. This is what is here. The same thing is common. So 1. This into 1 is this one. So this one multiplied by 4 to the power 1 will give you the first term. This one multiplied by 1 will give you the second term, is equal to 384. So 4 to the power 2x minus 2. In the bracket 4 to the power 1 we have, that is 4. 4 minus 1 is 3. So into 3. Into 3. 4 to the power 2x minus 2 into 3 is equal to 384. Children, I'm actually 5 minutes late for my next class. I'll just show you the answer slide and explain. I need to start the next meeting. So I'm here actually. Where am I? Oh, I've done this in a different way. Oh God. I've taken out 2 to the power x minus 1 common. Anything can be taken out common. Oh my God. Okay, let me finish. Where was I? I'll work this answer and send it to you. Where was I? 4 to the power?
4 to the power 2x minus
X
2
minus
into 3.
And I had taken 4 to the power 1 minus 1 is equal to 384. I'll work this answer and share it on WhatsApp with you children, because here I've done it in a different way. You can do it. You can take out anything common. You can take out x to the 2x minus 1 or 2x minus 2, anything common. So 4 to the power 2x minus 2 into 3 is equal to 384. 4 to the power 2x minus 2 is equal to 384 by 3. 4 to the power 2x minus 2 is equal to 3 1s are 3, 3 2s are 6, 3 8s are 24. So now 2 squared is 4 into 2x minus 2 is equal to 2 to the power 7. 128 is 2 to the power 7. 128 is 2 to the power 7. So I'm writing 4 also in base 2. 2 to the power 4x minus 4. 4x minus 4 is equal to 2 to the power 7. Base are same, so we equate the powers. 4x minus 4 is equal to 7. 4x is equal to 11. 7 plus 4, 11. X is equal to 11 by 4. X is equal to 11 by 4. I'll just work this answer on a piece of paper, and maybe tomorrow, because I have class till 9:30 today. Tomorrow I'll share the answer on WhatsApp with you. Please complete that in your classwork.
Yes, ma'am.
X is equal to 11 by 4. We'll repeat this in the next class, children. Don't worry if you've partially understood. Don't worry. We'll see it again in the next class. Very important question.
Yes, ma'am.
Okay.
All right, children. So that's for today's session. Thank you so much.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, children.